Hello everyone, my name is Prashant and I'm the founder of IdeaWeaver AI, where we work at the intersection of DevOps and artificial intelligence with a mission to simplify AI education for everyone. We run new learning batches every month for GenAI and for DevOps, and we have a course which is starting in the month of July. For the latest batches, dates, course details, and registration information, please visit our website. The link is available in the description. So, the topic for today is what does every word in the ChatGPT means? If I ask this question to anyone, this look like a simple question, but not many people they understand the meaning of it. So before we going to start to understand the meaning of this each and every terms which is involved in chat GPT, let's look back where everything got started. So on November 30, 2022, OpenAI released a product called ChatGPT. As I think many of us we are aware of that. Now, if you look at the first glance, it looked like another chatbot. Um, we have already seen the product like Siri, Alexa, Google Assistant, and many other conversational systems. But within 5 days, ChatGPT reaches 1 million users. Within 2 months, it crossed close to 100 million active users, which makes it one of the fastest growing consumer application in the history. So, one of the obvious question is what made ChatGPT so different? And to answer that question, we first need to understand what every word in the name ChatGPT actually means. But before we define the words, let's understand why ChatGPT became possible at the first place. So this is one of the diagram of the chatbot or the conversational AI, uh, or I will say how the evolution of conversational AI happened. So we also need to understand why earlier models struggle. So long before ChatGPT exists, researchers were already trying to build a machine that could understand language. So earlier neural network, such as recurrent neural network, process text one word at a time. So I know I use the word neural network here, which I have not explained to you guys. Some of you guys may be aware of this term. So I will explain this term at a later stage, but think of it like one of the early neural network at this point of time was something called recurrent neural network. So one of the major disadvantage of this is this thing. It processed one word at a time. So imagine if I'm going to ask a model, I grew up in India. Let's say I'm giving this sentence to our model. After completing my bachelor degree, I moved to the United States. Today I worked as an AI architect. Which country do I currently live in? For a human point of view, the answer is obvious. But for a RNN or recurrent neural network, remembering information introduced many words earlier is extremely difficult. So, for example, here I gave this sentence in the context of RNN, I gave it many sentences ago. And this is one of the major problem that it has a major problem in remembering the words which exist earlier. So think of it like as the sentence become longer, the earlier information gradually fades away, and the other uh, words or this term is also known as a long-term dependency. There are some other neural networks which exist after that, which is called LSTM, but they all have some kind of inherent problem. So fast forward from 1980s, 1997 to something called 2014-15, where there's something which has been introduced which is called attention. So at that point of a time, the researcher they asked a one simple question. So instead of remembering everything, why can't a model simply look back at the important word whenever it needs them? So think of it like this. Like we have this word 1, word 2, word 3, word 4, word 5. And at that point of a time, if we concentrate on this word 3, it only have access to word 1 and word 2. And like I mentioned, that these are something called hidden state. And the major problem with RNN is that as the sequence grow, it start forgetting all the earlier words. So let's say if we have the word 100, by the time it reaches to word 100, it start forgetting about the word 1 or word 100. And that problem we talked about is called long-term dependency. So what attention mechanism is doing is that instead of remembering everything, why can't a model simply look back at the important word whenever it needs them? And this whole idea is become attention. So remember this thing, because this idea of this attention was introduced in something called a Bandhana paper, which is this one. Many people think that the idea of the attention mechanism came out from Attention is All You Need paper, which we are going to discuss after this. But the main idea of attention came out from this Bandhanau paper. The what Attention is All You Need paper introduced is the idea of something called transformer, which is a key part of the GPT, but not the idea of attention. So now coming back to this main idea of this attention, this is the important point, that rather than treating every word equally, the model learned to focus only on the word which is most relevant to the current prediction. So what attention dramatically improved the language understanding. Now this is after this, the from 2014-15, then the major change which came out in the year 2017 when the transformer paper was released. And this was one of the major breakthrough. And this is the paper which introduced something called a transformer architecture. So like I mentioned earlier, in earlier neural network, for example, RNN, instead of reading text word by word, like how RNN works, it read word 1, then word 2, word 3. What transformer does it that it can process all words in parallel, and which help at the same time it learned the relationship between them using something called self-attention. So for example, let's take a simple example to understand this. So for example, if I use this sentence, Apple released a new laptop. So in this case, the apple is not a fruit. We are talking about a company called Apple. And that is pretty important because it is able to determine that here we are talking about the company, while because it learned the relationship between them, between the neighboring words. Similarly, if I use the word sentence like I ate an apple, here I am talking about the fruit apple, because looking at the neighboring words, it uses something called self-attention in the transformer architecture to learn the relationship between the neighboring words. So what transformer does, a transformer helps the model understand the difference, this difference from something called a context. So here Apple, we are talking in terms of company, and here I am talking about in terms of fruit apple. And what transformer does, because it's reading all the sentences in parallel or all the words in parallel, it helps the model to understand the difference from context. With context means in terms of the neighboring words. So if you look at all the current model, starting from GPT to Llama to Quen to DeepSeek, they all are built on the top of this transformer architecture. So now we understand a little bit of history, like how we have reached up to this point. Like we started with RNN, then we have attention, then we have transformer, then came out the GPT, and then all the models, they started following this this transformer based architecture. Now let's go back to our the main thing. The reason this lecture exists is to understand the each and every meaning, every word which present in ChatGPT. So as we know, the chat GPT consists of two parts. First part is chat and the second part is GPT. Chat we all know, but GPT stand for generative, P stand for pre-trained and T stand for transformer. Let's first start with chat. So the word chat simply means a conversation. So if I go to chat GPT and ask any question over here like what is AI, that is a chat, right? That's the chat or the interaction that is going on between me and chat GPT. So if you remember the earlier chatbot which exists, which required menus, buttons, and different kind of a syntax, here we are simply describing our task in terms of natural language. So that task can be anything. Like I will ask any kind of a programming question, any debugging question. I can ask him to summarize a research or ask him to write a poem, anything. And this conversational interface make this advanced AI accessible to everyone. Like prior to that, all these things is available to AI researcher. But because of this conversational interface where we are asking the question in natural language, this interface or this AI is now being accessible to everyone. Now, this one important point which we need to discuss is that there are two type of model which exist, or there are two stages in the model which exist. One is called pre-training and one is called the inference stage. We are going to discuss about the pre-train, which is the P part of ChatGPT, which is P stand for pre-training. But the inference process in the LLM is stateless. So what do I mean by that? That here, if we what we have done earlier, we have our input or a prompt, which we send it to the LLM, and we get the response back. Right? That is what it happened. Now let's look at the one problem. Like I ask a question, what is Kubernetes? Right? And it gave me the reply, whatever the LLM gave it to me. Then after that prompt, if I ask the question, can you explain that in simple terms? Now here, what do I mean by explain in simple terms? The Kubernetes should, my LM should have some kind of a context that I am asking in terms of Kubernetes and I am asking the LM to explain the Kubernetes in simple terms. But remember this point that LMs, they are stateless in nature. For them, each and every query that I'm asking to LLM is stateless, is a new query. So how does our LM knows that here I am asking the question related in terms of Kubernetes? So LM outside of it, they build a memory system which store this information. So next time when I'm asking this question like, can you explain this in simple terms? What LM is going to do is going to add all these information. So like I asked a question, what is Kubernetes? It gave me the answer. What LM is going to do, can you explain that in simple term? This prompt is now sent to the LM. And LMs are stateless, but because it has a context that I'm asking this question in terms of Kubernetes, it is going to explain Kubernetes in simple terms to me. So that is an important point to remember that LMs, they are stateless. They don't maintain any state, but what these big providers, the big labs like OpenAI or Anthropic or any of these providers, they build a memory system around it. And that memory holds that information. Okay. And when we are asking the question like, can you explain this, that in simple term, that along with the previous question is added and that we are passing it to the LM. Okay. So with this clear, let's look at the first part of this GPT, which is generative. P stand for pre-trained and T stand for transformer. And each of this word represent an important idea. Now, what the word generative means that model can create new content rather than retrieving the existing information. So the important point which we need to understand that when we are passing the input or prompt to the LLM and when it is generating a response here, it is generating a response or output one word at a time. I can show you with the help of this code. At this point of time, you don't need to understand this code. But the main idea is that after weeks of consistent training, the runner finally, if I'm asking this prompt to the any of the LLM, what it is going to do based on its training data, it has going to do something called a probability. And in that probabilistic distribution, the cross is the word which has a probability of 64.2%. And what it is going to happen that this word cross is then added here. And then this whole loop continue. Now the important point is when this loop is going to be broken. Like at what point of time LLM will stop generating a response. So there are two conditions which need to be met when after that LLM will come out from the loop. So basically we ask the question, for example this one, after weeks of consistent training the runner finally, it has the highest probability of this word called cross, and I said in the next iteration it is going to add cross over here. The point when it is going to stop when it is either hit something called maximum number of token limit, which we can define in the code, or as a part of a training it sees so many of these examples where it sees that for these kind of a sentence it need to stop at this point of a time. So either this maximum number of token limit need to be met, or it as a part of a training it has seen that at this point of time it need to be stopped. So that is the G part of generative GPT, where it is going to generate one token at a time. Now how it is generating that token, how it know that it need to generate this new token, that is the part of something called pre-trained or pre-training. But before we understand what pre-training means, we first need to understand something called a neural network. So our neural network is nothing but it is a mathematical model which is inspired by a human brain. The simplest way to understand the neural network is that think of a kid. So let's say a kid who never sees any dog or a cat. But with the passage of time, he sees so many dogs and cat, and then he is able to identify that this is a dog and this is a cat. So whenever he sees any new dog, based on the information which is stored in his brain in a area called dendrites, he is able to retrieve that information. Similar thing happened in case of a neural network also. We trained it with a vast amount of data. That is what it is done by these big labs like OpenAI or Anthropic and all those. So for example, if we take the example of Meta, they have trained it with this vast amount of data. This is one of the Meta paper where we have seen that they have trained it with this vast amount of data from Common Crawl, from GitHub, from Wikipedia, from Books, Archives, Tech Exchange. And what it is going to happen, okay, let me take a simple example. Let's say I am feeding this model or my neural network to the lots of images of a cat and a dog. And once this model is being trained, if we feed the image of a cat, it is able to determine that is a cat or a dog. So during the part of a training also, we does something called a validation. And in the validation stage, let's say if I feed an image of a cat and it predicts dog, that is something called a loss. And what neural network does at that point of a time, it performs something called a back propagation, where it moves in the backward direction and try to reduce that loss as much as possible. So that stage is called pre-training, where we trained with a vast amount of our data. The last part of this is T, which is called transformer, and we already discussed about it that this is the neural network architecture which is introduced in 2017 after the introduction of the attention mechanism, which is introduced by Pandhana. And rather than processing one word at a time, which was used to happen in case of a neural network like RNN, we are now processing all these words in parallel. And this architecture, the T part of transformer, forms the foundation of all the large language model which is available nowadays. So as we see that the name ChatGPT is not just a product name. It tells us the complete story of how modern AI works, where the chat part explains like how we as a human we interact with it. The generative part explain what the model does, like it generate one word at a time. The pre-trained explain how it learned, like how we train it with a large amount of our data. And transformer is the main underlying technology which powers this whole neural network. So thanks everyone for watching this video. If you enjoyed this video, don't forget to hit the like button and subscribe to the channel for more content like this. It really helps support the channel and let me know that you like to see more videos like this. Thank you once again.